Okay, Algebra 2 skills number 7, solve by factoring the difference of two perfect squares. And this is an important pattern for you to know. This difference of two squares pattern is pretty common. And what you're looking for are two perfect squares. That means you can take the square root of them, separated by a minus sign. And if we have a situation a squared minus b squared, that factors into a minus b times a plus b. And a quick explanation as to why, if you were to multiply these together, a times a and a times b and so forth, these are designed so that the middle two terms cancel out, leaving only a squared and b squared. And because it's negative times positive, you end up with a negative here. So that's the pattern that you're looking for. The zero product property says if I have two things that multiply to give you 0, then one of those two factors has to be 0. There's no way I can multiply two non-zero numbers together and get a zero product. So if you've got an equals 0 and you've got two things being multiplied, you know one of those is 0. So we're going to put that to use here. So we've got an equals 0, and what we need is to make this be two things multiplied together. But notice we have the pattern that we just talked about. Perfect square minus perfect square. So what times itself makes x squared? Well, that'd be x. What times itself makes 9? That'd be 3. So this factors into x minus 3 times x plus 3. And come to find out, it doesn't matter if you put the plus first or the minus first. Either way is fine. We now have zero product property. Equals 0, two things being multiplied together. So I know that either x minus 3 equals 0 or x plus 3 equals 0. These are both easy to solve. So in blue here I have our solutions 3 or negative 3. You may see that those solutions presented several ways. You could see them sometimes with a plus or minus operator, which means it's just an efficient way of saying 3 and negative 3 at the same time. Or you may see a solution set. These braces and the two numbers usually written in order inside the solution set. So if I put 3 here, it makes it true. If I put negative 3 here, it makes it true. Second example here to solve. This time we don't have that equals 0 we need, so let's get it by subtracting 121 from both sides. Same thing, perfect square minus perfect square. So what times itself makes 4x squared? Well, that'd be 2x. What times itself makes 121? That'd be 11. So it becomes 2x minus 11 and 2x plus 11. Again, you could put the plus first. But we have the zero product property. We have an equals 0. We have two things being multiplied together. So let's set them both equal to 0 and solve. So here's the fraction. Add 11 to both sides and divide by 2. You get 11 halves, negative 11 halves over here. And I won't show that what the solution says. A third example, I want to mention something here. This is just going to be a factor, so we're not going to say an equals 0. But we can do this with higher powers. Here we have a fourth power, but we still have the pattern. Perfect square, minus in between. Okay, so it's 9x squared times 9x squared is 81. X to the fourth. 1 times 1 is 1. Notice the color coding. Okay, the reason we have this colored is because this also factors as a difference of two squares. Okay, it's 3x times 3x makes 9x squared. 1 times 1, 1 times negative 1 would be negative 1. Notice that the one that had the plus, we generally do not factor. There is an obscure standard that says that would factor with i's, but we usually don't do that. So if you see a plus, most people are going to say that won't factor. Whereas if you see a minus, as long as you have perfect squares, it will factor.